Hello students, I am Pushpraj Gupta, Assistant Professor of Basic Science Department from Oriental College of Technology, Bhopal. Today I am going to present a presentation on topic definite integral as limit of sum. To understand definite integral as limit of sum, let us first evaluate the area of region PRSQP, where PRSQP in graph is the area between the curve y equal to fx, x-axis, and the ordinates x equal to a and x equal to b. Divide the interval AB into n equal subintervals denoted as x0, x1, x1, x2, x2, x3, and so on xn minus 1, xn, where x0 equal to a, x1 equal to a plus h, x2 equal to a plus 2h, and so on xn equal to a plus nh equal to b. Here n equal to b minus a upon h. Note that as n tends to infinity, h tends to 0. The region ABDM in the figure, it is clear that area of rectangle ABLC is less than area of the region ABDCA is less than area of the rectangle ABDM. Here it is clear that when h tends to 0, xr minus 1 tends to 0. It is class interval length. All these three area becomes nearly equal to each other. Hence, small sn equal to h fx0 plus fx1 plus fx2 and so on. In this is summation form. Consider equation 2. Capital Sn equal to h fx1 plus fx2 plus fx3. Here small sn denotes the sum of area of all lower rectangles and capital Sn denotes the sum of area of upper rectangles raised over the sub intervals xr minus 1 xr for r equal to 1 up to n respectively. To bring it into perspective, equation first can be written as small sn is less than area of the region PRSQP is less than capital Sn. As n tends to infinity, these strips becomes closer to each other. Further, it is assumed that the limiting value of 2 and 3 are the same in both cases and the common limiting value is the required area under the curve. Symbolically, we have limit n tends to infinity, capital Sn equal to limit n tends to infinity, small sn equal to area of the region PR SQP, and it is equal to integration a to b fx dx. This is the formula. Integration a to b fx dx equal to limit h tends to 0 h fa plus h plus fa plus 2h and so on fa plus n minus 1h. This is the problem. First, evaluate the integration a to b cos x dx as a limit of sum. Suppose fx equal to cos x and nh equal to b minus a. We know that by definition of definite integral as limit of sum. This is the formula. Put fx equal to cos x and we have this. This is the formula cos alpha plus beta plus cos alpha plus 2 beta up to cos alpha plus n minus 1 beta equal to cos alpha plus n minus 1 by 2 beta sin n beta by 2 upon sin beta by 2. According to this formula, this can be written in this form. As we know that theta upon sin theta or sin theta upon theta equal to 1 when theta tends to 0. So this is 1 cos a plus, in place of nh we put b minus a and in place of h we put 0. So this is 2 cos b plus a by 2 sin b minus a by 2, and by trigonometric formula 2 cos a sin b can written as sin a plus b minus sin a minus b. According to this formula we have sin b minus sin a. Thus integration a to b cos x dx equal to sin b minus sin a. Next problem. Evaluate integration a to b x dx given fx equal to x and nh equal to b minus a. This is the formula. I repeat it. Now come to integration a to b x dx equal to limit h tends to 0 h a plus h, a plus 2h, a plus n minus 1h. Here a is n times, that will becomes na, and plus h 1, 2, 3 up to n minus 1, and by arithmetic progression this can be written as n minus 1 into n by 2. Limit h tends to 0, multiply h nha plus nh minus h into nh by 2. In place of nh we put b minus a, and in place of h we put 0. So this is b minus a in bracket a plus b minus a by 2. This is b minus a, b plus a by 2. This is b square minus a square by 2. Hence integration of a to b x dx equal to b square minus a square by 2. Come to next problem. Using definite integral as a limit of sum, evaluate integration a to b e to the power x dx. Here fx equal to e to the power x and nh equal to b minus a. We know that by definition of definite integral as limit of sum, this is the formula. In place of fx we put e to the power x, and by putting this value we have e to the power a, e to the power a plus h, e to the power a plus 2h. According to index rule, e to the power a will be common here, and rest of term limit h tends to 0, h1 plus e to the power h plus e to the power 2h, and so on. This is the geometric progression. According to geometric progression, sum of n term can be written as a r to the power n minus 1 upon r minus 1. So according to this, e to the power h to the power n minus 1 upon e to the power h minus 1. E to the power nh can be written as b minus a, and e to the power h minus 1 upon h will be 1, as we know that by first principal derivative formula. So this is e to the power b minus a minus 1, and e to the power a will be already common here. Multiply e to the power a. So this is e to the power b minus e to the power a. That is the integration of a to b to the power x dx equal to e to the power b minus e to the power a